Okay, this is going to demonstrate the web interface for the AIC wireless solution for utility lighting. By opening up a internet browser, we're going to use Internet Explorer for this demonstration and typing in the IP address for the actual device itself. You'll enter into a login screen where you'll place secure credentials. Now this is where in programming we can establish who has access to the system with different permission levels for command and control or just to view. So we're going to log in obviously as an administrator so we can turn things on and off for the demonstration. This will take a moment to load. The very first time you enter into the session, the load time is dependent upon the internet connection. This demonstration is demonstrating two different levels of wireless. One, wireless from the office where the internet connection resides, shooting a half mile across to the city street where we then have our mesh network controlling the street lights. This is the entry point into the beta site where we have control for emergency lights, the street lights, an IP camera, and a water meter. To demonstrate this, I'm going to open up a separate window just so we can separate the screen and so you can see simultaneous control. So now we're going to log into the IP camera that's located on the pole where the Jace is located, which is our control web interface. Again, we're demonstrating two levels of wireless. This image is being transmitted via one of our wireless Ethernet radios. So we're going to minimize this screen just a slight bit so you can see the city street and the control at the same time. This street has decorative lights as well as normal street lights or cobra heads. This cobra head obviously is bent. There's a decorative light here. Our bullet is right on the top of this light. You can barely see it. And you can see over here another cobra head with decorative light, and our beta site runs vertically down this street and vertically down this street. We have individual and gang level control for a circuit. So let's go back to the control block. We're going to slide this screen over just a little bit so we can actually see what's going on. So we're going to click the lights tab, which takes us to the graphic that we designed for the city, and you'll see as I widen it what control functions you have on the screen. As soon as the data loads, as is now, you'll see what we have. Number one, just basic command functions to help you navigate within the system. Go back to the home page to log out of the system, to edit the master schedule, which would affect your sunrise sunset, and then being able to turn sunrise sunset control on or off. Again, navigation buttons for your emergency lights, water meter, and camera. What you see here is a representation of the first street, which we're going to demonstrate. You have an override button, which we'll demonstrate in a moment, and this is a command status. When you give a command, whether it's from a schedule or override, the command status will turn green or whatever color that you give it. The light status is based on an amperage reading. So if you tell the light to be on, we're not going to give you a true light status until we read current from the light, which is very important in knowing true status of your system. An incoming voltage, as you can see here, this is live data and it's changing as we're sitting here watching it, and then wattage, the device itself just sitting there. Now if we go to look at some of the functions of the system, we can go to a volt log. This is a log that we're monitoring real time of the voltage levels of the city street. You can see it's 31 May 2012 from 12 a.m. to current. This is 240.45. You can see it fluctuating all throughout the evening to current time, which is 9:55, which is the last log. Again, it's 10:59 here, but realize Chicago is an hour behind us. So we'll back up one screen, and we have the same functionality with amperage, light status, and wattage. All this information can be exported to a PDF or an Excel document for reporting. So now you have a better understanding of the actual screen. Let's see the power of the system. Right now the system, as you can see, is scheduled in the sunrise sunset control. Right now sunrise this morning was at 5:30, sunset is at 8:06. Current time is 9:58. So that means at 5:30 this morning with an offset of 10 minutes. So at 5:40 the lights came on. The offset is an important feature when it gets into energy management because it gives you the ability to say sunrise is at this time, but I want the lights to come on at this time, and you can put offsets in up to roughly 4 hours. We have a basic system set up right now with 10 minutes in the morning and 10 minutes in the evening, so the city's saving 20 minutes burn time per day. There is no advanced scheduling at this point, but as you can imagine, being able to turn lights on and off or alternate lights is another way to save on energy. Alright, so let me slide over, get the camera position where I want it, and we're going to go to bullet 11. Now because we installed the system, I know that bullet 11 resides on this light, bullet 12 resides on this light. So we're going to invoke an override control command, and there's always a 2-level process before any changes can be made to make sure you really want to do what you're saying you want to do. Right now, because we're in a schedule mode, it's asking you, are you sure you wish to invoke override control? We say yes. Then it gives you the options: override on, override off, and release. We want to override the light on. So when I click OK, if you'll watch the light, you'll start seeing it come on. At the same time, if you'll watch the command status, it will immediately turn green, but light status will not change until we start reading current. You'll see an inrush of wattage as the ballast fires the bulb and everything levels off. You'll see it drop down to around 170 combined watts between the two lights, which is a 90 watt and a 60 watt, with the ballast equals roughly 170. So let's give it the command on and see what happens. Alright, we got the command status. Light status again will not change until we read current. We're starting to read current. It's currently 5.2 amps and an inrush of 1011.2 watts. Now if you watch the bulb, you'll start seeing the lights come on. The wattage will level off again as the bulb fires up and then cools off. Keep in mind, my office is in Georgia and we just turned a city street light on in the city of Chicago. Alright, the light's on and leveled off at 170, roughly 169 now watts, still 240 volts at 0.7 amps. So now let's do bullet 12 over here. We want to override on, hit OK, same thing, command status, light status will change once we read current. We're reading current, so now if you watch the light, you should start seeing the light turn on. Alright, you can see the decorative light a little bit faster, and there goes the Cobra head. So now we're demonstrating the lights being on. So let's turn the lights off again, because our goal with this system is to save energy, so we don't want to be running the lights in the daytime. So we're going to go back to bullet 11. We want to issue an override control. Yes, we do. We want to override off and turn the light off. This is how you can see the speed of the system in response. We've issued the command, and within a second or two, light goes off. You'll see over here, current's dropping. We don't lose status until current is 0. Current is 0, light status is off. Override command, we want to do the same thing for this light. Override off, if you'll watch the lights, we hit OK. Light is off instantaneously. Current will start dropping, and we lose status as soon as we get 0 amperage. Now, the system has been demonstrated. What we want to do now is put the system back on schedule. So tonight at instead of being at 8:06, we want the lights to come on at an offset of 10 minutes. So we want to come on at 8:16. So we get saved 10 minutes. We want it to go back to schedule, so we have to come back to the override and tell it to release the override. This sends the system back to schedule mode. So we want to put both of these lights back into its original schedule. Keep in mind, when you override something, you're taking it off of the schedule. Now it's back on schedule. The lights are off. We can close the camera and expand the view, and that is the power of our system.